All right, I chose mine on underground dwellings. And sorry for the transition. I worked in the movie theater for almost 21 years, so I chose that curtain transition. Got the history, the pros and the cons. There's going to be some slight overlap between Mark and Samantha with the earth sheltered and earth ships. One thing that I did that might be a little different in the beginning is the history. You got what you have called south terrains, coming from the French word south terrains. As you can see in the images, this is circa 800 BCE. They were discovered with stone slabs and some timber. It's theorized. They're not sure of the true purpose, but it's theorized that they were arms storage during their wars. The province of Munster, these caves were found there, and I briefly looked up the Northman Doth and Noth. Let's see, what did I put here? Oh, this is the Boyne Valley in Ireland. Like I said previously, they theorized that this is where they stored arms at during the wars back there. Oh, excuse me, turn the heat on. All right, Scotland's another prominent area where caves were found, earth houses. The term Fogus was used to define these ancient caves. Several hundred have been discovered. And primary northern and eastern Scotland, the subterranean depths are different, though, in those areas. They're not consistent. And outside of Britain, you can find these caves or underground structures in Europe, China, Korea, and North America, and Scandinavia, which is where they're very prominent. These are the pros, and some of these are more relevant to the ancient structures and some are relative to the modern. Obviously, our ancestors wanted protection from the elements. Since they didn't have modern heating and cooling methods, they could maintain a consistent temperature and privacy and safety from warring tribes or creatures of the night. Now, a couple of these pros and cons will be related to the modern era. You got green space and excellent insulation provided by the living roof and low maintenance. The cons, there's a lot more. Obviously, there's poor ventilation and not good air quality, and obviously in the old structures. Not much natural light. Let's see. Water leaks, even back then, were a prominent disadvantage. Humidity would be high. Now, in the modern era, you got the issue of radon, which is very serious. Obviously, if you use this type of construction, you'd have to have a radon detector system. The problem is finding professionals with this particular type of construction. It's more and more common nowadays, but still people have to know how to excavate. The concrete and waterproofing systems are not eco-friendly. You got to worry about local building codes as you do with the earth ships and the earth shelters. You got to check your zoning issues before you even consider to build in an area. And one of the biggest things is once this is designed and built, you can't expand. And because it's so very unique, resale might be very difficult unless you can find someone with a common ideology. All right, going back to some of the history, you got two main types, which they're almost synonymous. I don't see how they actually distinguish, as you'll see in some of the images. You got your dugouts. Basically, our nation was formed from immigrants coming all over the world, but the main two that facilitated the dugouts and pit houses and underground houses, our ancestors were the Norwegians and Swedes. They had already perfected the methods in their own lands. Because I mentioned earlier, they wanted to get out of the elements and away from their enemies and creatures. So they brought their expertise over here and kept on building as they did in their homeland. As you can see here, this is an image of a dugout, and pit houses were basically the same. I had to use the same images, but the Swedes were the most prominent, as I mentioned earlier, to come over here and construct what you can see. They dig it out and use timbers. And the disadvantage of this method was the roofing. If you didn't have a good mesh, a good rain would wash it away. This is kind of what it looked on the outside. Oh yeah. One of the things that took place in 1860s in the United States, the Homestead Act was passed, which allowed migrating farmers to settle on a piece of land and farm it for several years, and then they were allowed to own it. Problem is, though, they were not engineers, so they could build a pretty good structure, but they were just farmers. So usually the sod roofs could cave in from rain or other elements. So sometimes they had to rebuild frequently. The good thing about these structures, they're self-sufficient and very energy efficient. As you can see here, that's a typical dugout on the left, and they're similar to what we can termed earth burned. You can see the cow standing on the roof. I'm not sure when this was taken. It looks like a long time ago. Pit houses is another style, but like I said, looking at the images, they're very similar. Now, the thing about the pit houses, they're older, supposedly. They go back 25,000 years ago in Europe, but they have been discovered in Utah as soon as a century ago, but they're about 5,000 years old. And our ancestors, or American Indian ancestors, in ancient Pueblo, the Fremont, and Alcaic were known to have constructed these. And I had to use the same images because they're very similar. I didn't see any real difference between the two when I was researching this. So I used the same images over. And, some were obviously better constructed than others. In areas where you might have had stone, you could have earth burned it. But like the one on the left, that probably was not very stable unless they had a heavy thatch to reinforce the roof. So it would have taken a lot of tree foliage to do that with. Now, I was surprised to find this. This is what was termed a long time ago as a hope house. The term implies that they would build just basically a basement, put a roof on it. And if they saved enough pennies, they could eventually build another level. Hence the term hope house. They hope had enough funds in the future to expand. Otherwise, they basically just lived in a basement their whole lives with a roof on it. This one is no longer in existence. So this photo is probably quite old. All right. This is a concept design that I found, but I was not able to find any real houses built in this manner. So I'm kind of curious about that. This is called the umbrella house, and you can see the airflow tubes. And the next thing, you see how the airflow changes pertaining to the various seasons. This is the basic construction. You got polyethylene insulation and also polystyrene sheets. I'm going to have to read this part because I can't remember the technical stuff. The polyethylene was synthesized by scientists in 1933 and reacted to ethylene with benzohyde under extreme heat and pressure. Now, polystyrene, on the other hand, is a polymer that's created from a monomer styrene, which is a liquid hydrogen carbon derived from petroleum. Now, like I said, I haven't found any actual photos of houses constructed in this manner, but it appears to be a valid design. Here you can see the various temperatures. And when I found this, I was surprised because I'd heard most of my life that typically temperatures below grade usually range around 45, 50, 55. But in this chart, it shows varying temperatures. And this has to do with obviously different climates around the country. So it probably could vary depending on where you're situated. But I've always been told it was or heard that it was around 50 degrees constant. So I have to do a little more research on that, why that varies so much. I think Mark had this in his slideshow. This is a typical template of a cross-section view of a very simplistic underground house. And there's always variations, but this just gives you a general idea of what it might look like if you just cut a slice through. And of course, there's multiple variations of this same thing. Now, this is something near and dear to my own heart. When I found this, I'm like, this brings back memories. In 1978, when I went to my college back home for the first time, my then instructor told us to choose a floor plan design to use for the year. Well, I remember an old movie, Eric might remember, the rest of you are too young. It's called The Andromeda Strain in 1971. It's about a 5-level underground biohazard facility, and it was circular. And that, between that and Star Trek, it inspired me to submit a 3-level circular underground design. Well, he poo-pooed it. He didn't like it. He said that's unpractical. No one would ever do anything like that. So I had to choose something else. I ended up doing an L-shaped plan. Well, I started subscribing to Popular Science in 1978. And I was still in other programs, even in 81. And I think it was the July issue of Popular Science. On the cover was not only the design, but the completed construction of a 3-level circular underground house, I think in Texas. Imagine how I felt. I took that magazine into school the next day and flopped it on my instructor's desk. And I said, you see there, this guy had the same idea about the same time I did, and you kept me from my dreaming. I'll never forget that. I still get upset every time I talk about it, but you know, I could have had a different future had he not let me do that. Here you see images of prefab. They're not as common yet, but I think in the near future, they will become more common because everything's turning to prefab. It's much more efficient to build it in a factory environment and then set it in place, although you're going to have more up cost. And the image on the right is a typical underground structure, obviously all concrete with a sod roof, but this one has a lot of daylight exposure. There's 3 types of the earth shelter, which kind of blended over into the underground. This is the in-hill, which I don't consider this the underground style at all. You can see it is actually all above ground. It's okay. We go next. Yeah. All right. Now this is the berm that was mentioned before. The difference here is bermed can be either have a sod roof or an open roof. And in many instances, you'll see solar panels as a energy substitution or to help with it. Okay. Now this is the true earth sheltered home because it should be below grade, at least on 3 walls to be determined underground. All right. The hidden cost are the excavation, usually 10 to 25% higher because of the renting of all the equipment, not only for excavation, which is extremely expensive, but even if it's not prefab, you more than likely have I-beams, steel I-beams that have to be lifted into place. So crane costs have to be considered as well. So the upfront costs are greater, but in the long run, due to low maintenance, it should even out. And here's some examples of kind of like earth bermed underground houses into hills. And when I first saw this, I thought of the Hobbits, the Lord of the Rings, and they actually do exist. I didn't get any images for the slideshow, but I've seen Hobbit houses that people actually live in. I think they were on Facebook when I saw them the first time. These are more modern, massive underground dwellings, and you can see they're quite open. A lot of one of the cons is supposedly limited sunlight, but that was our ancestors. The more modern ones exposure is not an issue. And not only can you do what is seen on the left, you can have multiple skylights as you see on the right. And that's very common. The only drawback, you really have to make sure it's sealed well, or you're going to have water issues. And some more images. I mean, these things vary in size and shape and design. They're all over different parts of the country. And they can be quite fancy, as you can see. There's no limit to the design, only your own imagination. Other things to consider is the climate in which you choose to build. You got to be careful about extreme temperature swings and the humidity factor, because it's basically a basement with dirt on top, and all basements are going to have high humidity. Hence, you probably need dehumidifiers. Or what I was thinking of is probably just have a fire pit, fireplace, or wood stove to heat it, as well as traditional heating, because that would eliminate a lot of the moisture. You got to consider any water nearby or on your property. You have to be careful and make sure you know which way the water is flowing before you even consider it, because if it's going to flow anywhere near the construction of the house, you're going to have to spend money to divert it and or water seal your house. Otherwise, you're going to have issues you cannot fix. So the topography and the type of soil is very important. You basically want gravel or sandy soil. Clay is not preferred because it holds a lot of moisture. And let's see. And that's it. Well, that didn't flood too bad, I guess. Eric, you're muted.
Sorry.
There you go.
Keep doing that. Well, I thought I opened it. There it is. I was trying to do a search of that one darn archaeological site, and I think this might be it. And it falls right in these type of underground dwellings where they had stacked rock, had some wood beams, some rock beams across through there, and then basically peat moss earth across through there to end up making their dwelling. And for some reason, I cannot find any information on this at all. And like you, when I was in architectural school, this was what I had studied, and I, for the life of me, cannot find it anyway. So I will find it eventually.
It's a fascinating history. That's why I chose to put all that in there.
Yeah. Oh, absolutely. Absolutely. I mean, you think underground, I mean, we first, as humans, we probably tried to, we were cavemen or so, so we're told. Not exactly in every climate did they, could you build a cave? But basic, the Mesa Verde, is a cool, cave dwelling. So when you're thinking about modern day houses, so we live in Western North Carolina. We dig, and most of the time here we have basements, or at least I don't know about most of the time, but there's a lot of daggum houses that have basements. And the biggest issue with every basement is water leakage. If it's not done properly, if it's not drainage has not been put in, this, that, and other thing, then you're definitely going to have a problem. So, why don't we have these hope houses anymore? Anybody, any thoughts on that?
You mean with the basement and the one level structure?
Yeah, I mean, why don't we have a basement with a roof on it, basically? Basements Go ahead.
I said condensation problems.
Well, we've got better technology today than they did when these hope houses were built.
True.
You know, we can put French drains all the way around it, at surface level and at floor level, get that water out of there, and you know, we're underground. I don't know, when it just seems to me that, you know, let's just say this, I can keep my basement at a better constant temperature than I can the first floor any day of the week, all year round.
True.
Hands down. Tell me about these earth tubes here, buddy.
I think that has more to do with the airflow to eliminate, you know, the humidity and the moisture. Like I said, I couldn't find a lot on this. I found these images, but couldn't find much information. I can go digging some more, but this looks like a very well thought out design. But like I said, I never found any images of an actual structure like this.
Mm-hmm.
So that's going to require some more research.
Yeah, it's definitely having to get that air in there, and you know, just using stacked effect. My concern is with this going back down under the earth rather than popping out up above, then you're going to have some sort of mechanical means to actually make this work. It couldn't work passively. Now we could, you know, we could definitely go in here and put us a little waterproof top.
I don't know why they didn't do it that way.
That way we're going to have, you know, it's going to work passively for sure.
Kind of like a chimney flue to draw the
Yeah.
air.
Yeah, absolutely.
I thought this was strange when I first came across it. I'm like, well, damn, how's that supposed to work?
Now this here, this comparison, there's no way in the world this comparison is in the same region. It seems to me like, you know, this comparison is North Carolina, Western North Carolina, and this comparison is Canada.
Yep.
You're not going to have quite so deep changes unless this is inches. If it's feet, it's wrong. But if it's inches, I could understand it.
Oh yeah, I didn't even think of that. I see the demarcation lines now, so I don't know.
Yeah. Yeah, if it's inches, you know, 20 inches down, depending again where you're at, you know, the frost line is 48 inches in Rochester, New York, and it's 12 inches here in Burke County. It's 18 inches in Boone, and so you know it is going to vary. But after you get, you know, if we get 20 feet, unless we're in the Antarctic or the Arctic Circle, if we get to 20 feet, I mean, it's just going to be froze for a long time. But where we have a mixed climate, it's not going to vary that far down.
Yeah, when I saw that, I was kind of like, well, I don't know where they came up with this. I mean, it looks kind of old based on the cartoon effect. Like maybe this must have been previous notions before they actually scientifically validated it.
Yeah. I see here on this drawing, they're talking about the tubes as well. We got the lower tube entering the house, and then the upper tube exiting the house. But again, if it drops down to an equal size, then we can't do that passively. We have to keep that higher.
You'd have to have fans in the tubes, correct?
Yeah, absolutely.
Yeah, hey, I touched upon that in my geothermal presentation. Like once you're a certain depth down the ground, usually the temperature stays like 50 degrees or so.
Yeah.
That's where they get that energy from. So the temperature down there stays constant.
But now where, you know, the further you get towards the equator, the deeper that 50-degree mark is going to be. And, or no, I take it. Well, yeah. So let's say if we take the equator and the Arctic Circle, those you're going to have to be, you know, you might be 20 foot deep before you get to 50 degrees, because in the tropics, the sun's hitting that all the time. And, you know, so it's going to be hotter further down. And then in the Arctic Circle, or in the Arctic circles, Arctic poles, then, it's going to be frozen that far down. But, in Western North Carolina, it's going to vary, and it's not going to change quite so much. Oh, heat sinks. So you think about Interstate 40. Think about Walmart parking lot. What color is that asphalt? Black. The temperature underneath that ground in the summertime or in the wintertime is going to be very much more higher temperatures than the surrounding areas. And so it's heat sink is a big thing to have to deal with. When I was growing up, and bless your heart, Timothy, I know you think you and I are about the same age, but I think you got a couple more years on me, because I don't even remember
6 years.
I don't even
I'm 6
remember
years old.
1971. I was born in 1966, but I don't, I
I was
wasn't
already watching Star Trek by then.
So, I remember when all of the interstates were concrete.
Oh, yeah. I remember that.
When it snowed, by God, it would immediately settle on that concrete and start piling up. Whereas today, it can snow and snow and snow and snow and snow, and it might start laying on the roads because the roads are so hot because of that heat sink, because it's absorbing. I have seen where some of these abandoned silos are being sold to privateers, and they're building houses in these darn things.
I have seen those myself.
So it's it's pretty cool to think that, it's kind of scary at the same time. They have buildings in China that are so large and so tall that and have every possible amenity that a person could ever need inside the building, such as schools, doctor's offices, dentist office, movie theaters, everything. And there have been reports of some humans have never touched Earth. They have been in this building their entire lives, and they've never been outside and actually touched ground, Earth. So think about, if push comes to shove, and we're in a, if we have this nuclear war thing going on that, was big back in the 60s during the Cold War, underground houses, we might have to go into hibernation and live in these underground houses till radiation levels drop so that we can revisit the Earth. But then, you're thinking you're going to have to reuse this air in here. And so you're probably going to have hydroponic systems in here, aquaponic systems in here, so that you can totally cut yourself off from the outside world. And that's a scary thing. But now, here we just landed on Mars with a new rover, and so we're starting to, think about colonization. Why in the hell, why don't we just start taking better care of our own planet? I don't know. But, if we can build a house on Mars, why couldn't we build a house in the Atlantic Ocean or the Pacific Ocean? Maybe because of pressure. I don't know. Any number of things could be going on there. So these prefab units that we're thinking about here. So these are made of plastics, and we're told that you throw plastic away and it takes 800 years to degrade. So does that mean that if we cover all this plastic up and it doesn't get any UV light, then this stuff's going to last 800 years? That's a good question. Something to think about there.
One thing I thought of after the fact was I keep up with a lot of modern building constructions, and you have those pre-cast like styrofoam forms that they form the basement walls in, and they got the plastic snaps to hold it all together, and then you put the rebar in. I mean, basically that can be, that's for most base houses with basements, but this when I was listening to Mark and Samantha, I was thinking about all that I'd studied over the years that, I mean, that's the modern wave now to use these forms that you take away. And you have a solid concrete wall, with rebar. And I mean, they've come, I mean, a child could put it, it's like Lego. You put it together and then they've got the formula for the cement damn well perfected. And I mean, the trucks are constantly rolling. I watched many videos on this. I mean, that's the way to go, not only for basements, but, even for above grade. And I'm surprised you don't see that much more of it. But I mean, if you're going to do an underground house, this would be the way to do it, I think, rather than having prefab, which would be very expensive.
Another type of prefab is superior wall systems, which is, they're made in a pristine environment, concrete. It's not going to have, probably not going to have the insulation properties that there it is. This is insulated concrete form, and this insulation stays there. So it's.
Oh, you don't take it away?
Nope, it stays there.
Okay.
Yep, it is poured, and then you stucco the outside. Well, you waterproof the outside, stucco it, and then you can, on the inside, you can go and put drywall or whatever you want there. So yeah, it's pretty cool.
Now is that a styrofoam composite or what is that?
You can get it this is expanded polystyrene, this is extruded polystyrene, and you can get both of those. Basically, like you said, they come in a block form like Legos. Has plastic little pieces in it that keep them together. And then you basically just go and fill it full of rebar in both directions. So you have to make basically a mat, a mesh inside the wall, and then you pour it with concrete. The biggest problem is how much lift you can pour. And what I mean by lift is, so we can only pour a certain feet all the way around it, let it cure, and then come back and keep going around. We can't just pour the whole thing full to the top.
I think it's either 2 or 4 feet because I've watched videos on this. So
it's manufacturer specific. So different manufacturers set their own rate of pour limits. So for sure. But yeah, these two systems right here would be great to work underground. This system here, of course, is a cast in place system. So you got to build the walls, put the rebar in, and then pour your concrete. This system is a precast, which means that you can you can have these entire walls set in, less than a day. But then, what are you going to do for your roof? By putting it, by making it underground, you're going to definitely have to go in and start doing some reinforced beams and stuff in here, maybe lightweight concrete roof, or you could do like that hope house and just come, a foot or so up out of the ground and start putting your roof there and be done with it.
Are those metal studs in there?
They are.
Okay. I hadn't seen that style before. The other one I'm familiar with. This is new to me.
Yep.
And these are called superior walls. I got to look.
Superior wall. Mm-hmm.
The construction industry is wide open right now. I mean,
once we're done, I'll be doing a couple extra little. We'll talk about some other traditional builds and stuff, and I'll talk a little bit more about the superior walls and the ICFs and so forth. Any other questions for Mr. Timothy? Any other comments?